All right, everybody, as we continue our study in that's the dog, chapter 8, section 3, we're going to talk about rational functions and their graphs. Now, our goal is to talk about properties of rational functions, but before we talk about their property, we better define what is a rational function.
Aren't you going to introduce me?
Oh, I have my husband here. Say hi.
They can't talk to me. You tell me to say hi to them. Hi.
Okay. A rational function, it's more entertaining when he's here, is when you have an expression on the top and an expression on the bottom. But do you remember what an expression is versus an equation?
Like smiling?
No, no. An expression would be something like x plus 5 over, I don't know, x squared minus 10.
No equal sign, huh?
No equal sign for those, just like regular old expressions. Okay, so that makes a rational function. Good to go?
Sure.
Great. Okay. So this is a rational function because, look, it has these expressions, right? Now, do you see this really cool, like, little, I don't know.
It's like a bird.
Bird graph. That's right. It just so happens that that's the graph that you would get. And looky, Archway Cookie, I'll put it on Desmo so they can see it. Isn't that neat?
Yes. Okay. Wonderful.
All right. So you could plug in x values to figure out what their corresponding y values would be, but that would be the shape that you get. Now, what I'm going to tell them now is this particular vocab term. Would you like to care to guess what that vocab term is?
Well, you're circling it, so I'm going to say continuous graph.
Yes, but continuous graph means this. It means you can trace your pencil on this graph and not pick it up. See how it like just kept going forever and ever?
It's very smooth.
Yeah, this one kind of like, this one kind of.
You just picked up your pencil.
What? Okay, you get what I mean. Like, okay. Thank you for that. Okay, so that's called a continuous graph. Now, the reason it's called a continuous graph is because I can't make the denominator equal 0. Now, you might say, yeah, you can. All you need to do is set it equal to 0 and see what the value is, right?
You can't square something to get,
yeah, because
tricky.
If you take away 1 from both sides, what do you get?
-1.
And then if you square root that, that's
can't do that.
That's imaginary. That's the dog. That's imaginary, right? So you know what? That's really no real problem.
No good.
You get it? It's no real problem.
Okay,
like because it's an imaginary versus a real. But really, it's no real problem.
Do all math teachers like their puns?
So this is called a continuous graph because I can't screw up the denominator. There's no real value of x to make the denominator 0. Got it?
Got it.
All right. Now what we're going to do is we're going to talk about these two. These two here, both of these are what we call discontinuous graphs. Are you ready?
I'm ready.
Okay. This is discontinuous because there is a number that would make this denominator 0. Do you know what that number is?
I'm going to go with -2.
You're such a smart kid. So if you do x plus 2 equals 0 and you subtract 2, you get that magic number that my husband just said. And no, he doesn't have the answer key. He's just that smart.
Wow.
That is a no-go. Okay? Because if you plug -2 in, you try to divide, and you'll get 0 on the bottom. And if you try to divide by 0... it blows up. So you can see right here at -2, that might not be easy for them to see. You can see right here at -2, we have this like open weird dot.
Looks like a spinner on a game board.
Okay, it's not though, okay? So this is called a discontinuous graph because there's a value that we can't plug in, like -2. But,
removable discontinuity?
This has removable discontinuity. That's a hard word to say. I'm going to know who listened to their notes and who didn't. Because they're going to say it the wrong way, like some people. Discontinuity. This has removable discontinuity. Would you like to know why?
Because you can get rid of something?
Yes. So you can cancel the x plus 2 in the numerator with the x plus 2 in the
denominator.
And you can remove the discontinuity. So watch. Here it goes.
I don't wear watches.
See this? You can boom and boom. Those can cancel, right? And what are you left with? You're just left with...
y equals x plus 3?
Yeah, you're left with y equals x plus 3, which surely I can plug in -2 now, right?
Absolutely.
So if I want to plug in -2, what do I end up getting? What do I end up getting on it? So that is why right here I wrote, if you cancel it out, when you plug in -2, you can get out a +1. So because you can cancel out, this is called...
removable discontinuity.
Thank you so much. Uh-oh. This one is not going to have removable
discontinuity. That's why it says non-removable right
That's
there.
right.
Non-removable
now let's talk about why this one has...
Let's talk about it.
Okay, so it's definitely a rational function because it has an expression and an expression. And the denominator I can solve, right? I can make it 0, and I can say 2. X is 2, and that's no good, right?
No good.
That's why, hey, look at, like, see how at 2, it kind of, like, blows up the graph. It, like, it's like, I'm going to touch 2, just joking. I'm going to touch 2, just joking. It can't.
Oh.
Did you see that?
It's funny. It's a trickster.
Okay, it is a trickster. That's right. And there is no way, like, I know a lot of kids think I can, like, cancel that out, just so you know it's, like, not a thing, okay?
Right.
It's called bits and pieces. But, like, this x minus 2 it's not up here, right? Like, I can't do that because it doesn't exist.
Not yet, anyway.
No, it doesn't exist. Okay. And you can't just, like, change it. So this is called...
non-removable discontinuity.
Because it didn't cancel out.
Uh-huh.
So far, so good.
Right.
All right, I like vocabulary. I think it's important. All right, now what we're going to do is we're going to see if we can repeat that on our own without graphs that were already given to us. Are you ready? So, part A.
I'm ready.
Okay, I really hope this sound's on. I didn't check.
One way to find out.
Should I stop it?
Yeah.
Okay, should I?
Just roll with it.
Okay. Now, don't worry about the top. Wait, actually worry about the top. Does that factor?
That's a negative.
That's right. There's no GCF. There's no squared, so it's not going to factor.
Greatest common factor. I remember that.
Now, do you think this one could potentially factor?
Well, you have an x squared, so there's a possibility.
That's
here.
right. So at this
let's
point,
see. Hold on. Let me think.
I would love for my students to pause their video and try
Uh-huh.
to factor it on their own.
Oh.
Okay, everybody, pause your video and factor it on your own.
My wheels are spinning.
Okay, I'm gonna wait. We can They're not pausing their video, because I know them because I've been teaching for 15 years. There's probably about 5 out of 50 that just tried. Okay. Do you know what you got?
Let's see. So factors of 3 that give you -4. Is that what I'm looking at?
Yeah.
Oh, right there.
Those are the ones. However, that's not right. Yes, it is. That is right. Okay, got it. All right, just want to make sure I did that right? If you guys, hopefully you did the whole ACB process if you're unfamiliar with how to take that shortcut. If not, we have a problem. We need to stop. You need to stay after because factoring is like a basic for this particular chapter. I'm not going to reteach it. If you need help with that you need to stay after. Okay?
I can't stay after. I'm sorry.
Oh, my dear heavens. Okay, so your domain is, I want you to say x equals.
Me or
Yep,
them?
you.
X equals.
All
You
real
don't have to
numbers.
just say
All
X
real
equals.
numbers.
All real numbers.
Except
Except
the ones that would make your denominator 0.
So 1 or 3.
Now, just in case there are some kids who are like you, they think that you have an answer key, which you definitely do not.
No, I'm just looking at, x minus 1. So 1
they don't
minus
see
1
you
would
pointing.
be-
He's pointing at this.
Yeah, 1 minus 1 is 0. Yeah.
And he's saying, okay, so if x minus 1 was 0, that would be bad, and then that would make x
Yes.
equal 1, and that
Yes.
would be sad.
Bad then sad.
Okay,
And
and then
then
this would be
And
x
then glad.
this would be x minus 3 is 0, and then if you add 3, you get 3.
Yeah.
And that would also be sad because it would make you mad because you would be dividing by 0.
And
so
I'd
that's
rather
where
be
that
glad.
and the numerator can be 0. Did you notice I didn't like care about the numerator at all?
Aw,
Okay.
that's mean.
All right, so that's your domain. Points of
Discontinuity.
thank you very much are. Can you tell?
I'm going to guess 1 and 3.
I think that was a really good guess. X equals 1 and x equals 3. If we graphed them, we wouldn't like have a graph at those spots.
Correct.
Or something weird would happen there.
Right, and we don't.
We don't weirdness.
I'm weird.
You are. Do you think these are removable or non-removable? What is your guess? Just based off what we did on the first page. Do you think they're removable or non-removable? You know what I'm trying to say.
Well, here's the thing. I forget the difference already.
Oh, removable means they can cancel
Well,
out.
no. Wait, they can cancel out?
Yeah, like over here. Like, here, let me highlight
Oh,
for
no,
you.
nothing's canceling out over there.
Like, what about the x minus 3 and the x plus 3? You don't think those cancel out?
Well, they have different signs.
That's
so I'm
right, they
guessing
don't
no.
cancel out. I tried to trick you. You didn't fall for it.
I did not.
Okay. Just so you know, I'm really tricky. Okay, so these would be called
Non-removable.
non-removable. Removable. Because why? Nothing cancels. Okay.
So I'm remembering the rules
So far,
now.
so good?
Yes.
All right, now, this wasn't in the notes up above, but, like, I feel like kids should know what an x-intercept is.
Where it crosses the x-axis?
When y is...
0?
That is correct. So, let's make y 0 and solve for x, shall we?
Sure.
Are you ready?
That's one of those. Is that one of those like ASMR things? The noises there that people find soothing.
Yeah, it is soothing. Okay, so if you multiply both sides by this, it'll move it to the other side.
Mm-hmm.
So if I multiply 0 by this,
You get 0.
You get 0. Okay, good. Thanks for understanding that.
Tricky. So x
And
equals
then-
-3.
So your x-intercept happens at -3. In other words, it'll cross the x-axis at -3.
Mm-hmm.
Just remember, when you multiply 0 by this denominator, you get...
0.
Okay. Now
Anything
the
multiplied by
y-intercept...
0 is 0.
What about the
remember.
y-intercept? That's when what is...
I'm going to go with x equals 0.
That is correct. Okay, let's do that. So let's grab our equation over here. I feel like this time I could probably just rewrite it, but that's okay.
Probably, but then you couldn't show off your cool iPadding skills. I just made that a work verb.
iPadding. Okay, so we have to make x equal to 0. You ready?
Oh, I'm ready.
So boom, 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 boom.
Mm-hmm.
That's going to be what in the top?
3.
And what in that first parenthesis?
-1.
And what in the second parenthesis?
-3.
And that's going to be 3.
3 over 3.
Which is...
1.
Okay, now what we're going to do is, I haven't tried this yet, but we're going to graph it and see if we're happy with what we got.
Did we do good math?
I don't know.
Did we do good
We'll
mathing?
Okay, we'll put Desmos right here. We'll X out, and we're going to have to type this in. Y equals...
You talk to Desmos like it's your friend.
It is my friend.
Oh.
Okay, I need to
You might
divide
need some
by
help.
sign. Okay, so I need x plus 3 on the top, right? I could type this original in, or I could type the bottom in. Should I just do the parenthesis thing?
Sure, I'm
Since
not really
that's-
following you, but yeah.
Well, I was saying, like, I
What do
could
you
type
mean the
this in
original?
or this in. They're the
I see.
same.
I got you. The
I don't know why. I
factored.
just think it looks prettier that way. Oh, wow. Look at that. Okay,
That's
so remember
funky.
we said something weird happens at 1, something weird happens at 3, and we have these intercepts. Are we ready?
I'm ready.
Okay, let's see if we're happy with what we see. Okay, so we should see something funny happening at 1 and 3. Well, here's 1.
Nothing's.
Well, yeah, no, you see how, like, I can't, like, I guess I could screenshot it.
This one's trying to touch one, but it won't touch one.
That's right. Okay, here, let's
It'll forever get closer.
just
and closer and
screenshot it so we
closer.
can, like, actually write on it. Okay, so, yeah. So, like, at 1, you see how it's not, like, touching at 1? It, like, approaches it, but it never touches. And that happens at 3 as well, see?
Ooh.
Isn't that kind of cool? So, like, not at some weird stuff happens at 1 and 3.
Mm-hmm.
So that made sense?
Mm-hmm.
The kids should understand that if they're watching their notes. Okay, and let's take a look at the x-intercept of -3. Oh, look at that. Sure enough. See where it's crossing? -3. And let's take a look at this y equals +1. Does it cross at +1? Boom, 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 boom. Yes, it does. See right there? It crosses at +1.
Look at that.
So there you go. We found the x-intercepts. We found the y-intercepts. I even think Desmos will do a table. I think I'm getting overambitious at this point. Like if I type in 0 for x, and then can I type in for y? I can't. Okay. Oh, I angered it. That's okay. Let's pretend that part didn't. The notes didn't happen. Okay. All right. Let's try again. So we did well.
Oh, I think so.
I mean, I'm pretty happy with what I saw. First time teaching this lesson, like in ever. So it's good. It's good so far, right?
I'm learning.
Okay, great. Okay, now I need you to look at this denominator.
Yes.
Do you think it factors?
I am gonna say. I'm gonna go with. I'm gonna go yes.
All right. Well, here's the good news.
I don't know.
Here's the
I
good
can try it
news.
out.
Here's the good news. You ready?
I'm ready.
For the good news, they learned how to factor. This is called the sum of perfect squares. I'm going to blow some of their minds right now. They're going to tell me I never taught them this. But that's how you factor that. What do you think those eyes are? Would you like to use the word imaginary?
No. What would you like me to use the word imaginary?
I would like.
Sure.
Yeah. So this only factors with imaginary numbers because it's the ready. Watch this vocabulary that I told them to remember. Sum of perfect squares. So we learned that, by the way, guys, in chapter 4, section 8. It was your favorite. But if you're not sure or not, you can always set it equal to 0. And
for future reference,
guess
I
what?
hope you don't change textbooks because that 4.8 might not always be 4.8.
We learned it when we studied complex numbers. Okay, now, since it doesn't factor, does anything cancel?
No.
No. Okay.
You can't take an x out of x. No, it doesn't work.
No. Okay, so we're supposed to find our domain
Yes.
now. So our domain is x equals, guess what?
Real numbers.
And there's no like bad things that can happen to the denominator, right? Because then we say
it, equal to 0.
it would be like the square root of -1 because we did that previously. It's impossible.
Something.
Okay, so all real numbers. Points of discontinuity. Any? What do you think?
No.
Yeah, I don't think so either. So no points of discontinuity. That's a really hard word for me to say. So NA, so therefore they're not removable or
Right.
non-removable. But let's go ahead and do the x-intercepts. Doesn't that sound like fun? Let's do a quick duplicate.
Our definition of fun might differ, but hey.
Let's do another duplicate. Did you realize how I just ignored you?
Nope. You ignore me?
So we're going to do x-intercept. So what do I make 0 for x-intercepts?
The y.
Mm-hmm. And what would I multiply both sides by?
The denominator.
So I'm going to multiply by on this side, so it goes away. And I'll multiply it over here. And what do you end up getting?
0.
Equals.
X minus 5.
And what would do both sides?
So you add 5.
And you get 5 equals.
X.
And that's your x-intercept. We're going to graph it on Desmos and see if we're right or wrong.
Verify.
That's right. If we're wrong, we're just going to cut this part out of the video. All right. And now I need to do, what is this one?
Y-intercept.
Which means x is 0.
Mm.
Okay, so y equals 0.
Your y looks like
0.
a official.
That was distracting. Like, seriously, we're talking to poor teenagers listening to this for the first time. And what do you end up getting?
All right, so
Those
negative
watching.
5 on top.
And?
1 on the bottom.
And?
So it makes negative 5.
Okay, let's take a look at Desmos and see how we did, shall we?
So 5, negative 5.
Sometimes I get nervous when I haven't...
What, that you're wrong?
Yeah, I don't like being wrong. Y equals... What was it? Do you remember?
Negative 5.
No, what was the whole equation?
Oh.
Y equals...
I don't know.
It was a fraction.
I don't remember.
It was y equals x minus 5 and x squared plus 1.
We got this.
X...
Minus 5.
Oh, poo. I'm not deleting that. Oh, dear. Hey, maybe now they're typing it in because I went slower.
X squared plus 1. Is that what it was?
X squared. Yeah. Okay, here's our graph. Let's find it, shall we?
So, the x...
Oh my gosh, it's so beautiful. Okay, so notice like no discontinuity, right? Like you can trace the whole thing. Didn't we say the y-intercept was negative 5?
Mm-hmm.
Well, there it is. You see it right there. Boom, boom, negative 5. Oh, look how like kind of weird it is. But you can see it across the negative 5.
Yeah.
And didn't we say what was our x-intercept? Wasn't it positive 5?
Mm-hmm.
Whoa. And if I really, really, really wanted to, you can see.
So you're telling me that there's no x-intercept on the other side of the y-axis? Is that what you're trying to tell me?
It must have some type of weird asymptote.
A little wonky?
It must have some type
You're
of weird asymptote.
telling me it doesn't go across?
Look
at that.
Whoa.
See, I would have, just looking at it, wouldn't you have assumed that there would be some sort of another x
Right now I'm just focused on algebra 2, nothing above that. So
that's where my mind went. I was like,
I know. It's beautiful.
Again, our definitions might differ.
You think I'm beautiful.
Well, that's true.
Thanks. Okay. Thank you for this. Okay. Next one. All right. Well, do you think something factors on here?
Sure. We can try it.
Do you think maybe the students should? What do you think I'm going to say?
Pause the video.
And try to
do it on their own.
That's right. Now this is kind of an easy factoring one because A is 1.
Mm-hmm.
So if they could just by chance think of things that multiply to negative 4 and add to negative 3, I mean, they might get it. They don't have to. They could do the whole AC.
That's how I like
chart.
the factor. I don't like the chart as much. I
well,
personally like.
Hey, time out.
What?
You need the chart if A isn't 1.
Oh, that is a good point.
Thank you.
That is a good point.
Thank you. I only make good points. Thank you.
Well, I might need the chart.
All right. Did you figure out your numbers yet?
You don't know how smart I am.
It's negative 4 and positive 1. That was really good. Oh, do you see something?
Yeah, x minus 4.
Okay. This is a lot more fun when you're here.
Maybe your students think so too?
They do.
Or maybe they think I'm annoying. Who knows?
Nope. All right. So let's talk about the denominator. Is there anything that would make us sad?
Yeah.
If
x equaled 4.
That's because x minus 4 is not
right.
allowed to be 0. So if we add 4, that would make us sad.
Mm-hmm.
So let's talk about our domain. What do you think our domain is? Have you caught on?
I'm going to go with 4.
How about all real numbers?
What do you mean?
Except.
Except 4. Yeah.
Except x equal 4. So it's, you can plug in anything. You could plug in 4.2. You could plug in 4.0000002. Just don't plug in 4.
I think your point is well made.
Thank you.
Anything except 4.
Okay, and then we need to do the points of discontinuity would be.
I'm going to go with 4.
Good. What do you think about this whole removable and non-removable thing? Do you think that that's...
Well, since we can we can cancel out.
Because they match, those binomials match, they would cancel?
Is that considered part of an expression or something?
Yes.
Yeah.
Sure. Okay, so since they canceled out, since that goes away, we could say this is what we call a removable. It's removable.
Yeah.
Okay. Hey, by the way, what would we get if we removed it? If removed, what would y be?
X plus 1.
Okay. And what about if we plug in 4?
Oh, 4 plus 1 is 5.
So we would get 5 if we removed it.
Yes.
Okay. Now, the next thing we have to do is find our intercepts. This intercept here was our x-intercept, right?
I wonder if I could intercept a football that was float.
Don't do that. Don't do that.
It's like it's traveling through the air.
That was our equation. That's my goal was like to do the equation. I think I did a great job.
Mm-hmm.
Okay, so ready? X-intercept make
y 0.
Okay, so 0 equals all that stuff. What would you multiply both sides by?
X minus 4.
And if you multiply this by x minus 4, it goes away. And if you multiply this by x minus 4, it stays
0.
So you get 0 equals these magic numbers. And then we learned in chapter, you just set each of these equal to 0 and solve. What would x equal here?
Negative 1.
There you go. So
two intercepts.
2 x-intercepts. Oh, ready for the y-intercept? What do we do?
As ready as I'll ever be,
What do we do for the y-intercept? Make
x 0.
Okay, so there's that. Let's go ahead and make that x into a 0.
Y there a little. Oh, look at you. Wow.
Okay, so make that and that 0. Ready? 0.
I'm ready.
0. Y equals, what's the first parenthesis?
Negative 4.
What's the second parenthesis?
Positive 1.
Bottom.
Negative 4.
Okay, multiply the top.
So you have negative 4.
Over the bottom.
Over negative 4 is 1.
Ready to use some Desmos up in here?
Yes.
Me too. Do you remember what I don't remember what it was, do you?
When you said up in here, it made me think of an old song. Is that a good story?
No.
Okay.
Tell them what classes you teach while I'm typing this in so they know how boring.
Stuff.
Go no, seriously, tell them.
Which
you
ones?
don't want the fun ones, the one that's there like, boy, I wish I was there and not here.
True crime. Yeah. Serial killers and stuff. Right now we're doing a class on scandals, cover-ups, cults.
Okay, thank you. That's all I needed. Okay, thank you. I needed the time. I appreciate that. So I
That
graphed
was
it.
filler.
Yeah, you ready? So we need to see if this stuff holds true on Desmos or if Desmos has issues. All right, what about at x equals 4? So you know what they did? They must have removed it for us because, look, it does look continuous. So when it's on Desmos and it's removable, look, they actually do it. Looks like a, so remember we should have a problem at 4. And what did we...
wonky?
What should we have when we plug in, remember like right here, when it's removed and you plug in 4, you should get 5. Let's check this out. 1, 2, 3, 4, 1, 2, 3, 4. There it is. I don't know why it doesn't want to work for me. There we go. So when we get to 4, sorry, we should have 5, right? There it is. I mean, I was tracing it, but you see how it is? Oh, look, it says 4 is exactly undefined. Oh, I wish I could get it there.
It's bouncing on the...
They saw it, right?
Yeah.
If they're watching.
Yeah, undefined.
Oh, I can't do it. All right, but that's cool, though. But they can see how it approaches 5 infinitely until we have an issue. Let's check out our intercepts. We should have one at 4 and one at -1. But we don't.
Oh, I see your y-intercept already. I jumped ahead.
Y-intercept is good. Y-intercept is good. So the question is, why don't we have these x-intercepts that I want? Wait, -1.
Zoom out.
Hold on.
Yeah, there's -1.
It's -1, but remember, I know why we don't have, here's -1. I know why we don't have one at -4.
Because that's
It was a discontinuous point.
Until they.
Yeah, so that one, we don't want that. That's not going to be,
no good.
because it's one of our points of discontinuity. It's not going to be an intercept. Whoa.
See, it's a good thing we did this.
Yeah. Tell the kids goodbye now.
Goodbye now.